In this video, I'm going to demonstrate how to determine if there is a significant difference in district enrollment between Region 1 and Region 5. So in SPSS, we do a pre-test checklist that includes the number value, which is the quota, normality, and homogeneity of variance. So let's go. I've already pre-selected the data due to time restraints. So when we look at Region 1, we see the number value is 72. This shows that it meets our number value criteria. Also, when we look at the histogram, the data is not normally distributed in Region 1. As we scroll down to Region 5, when we look at the number is 23. So we know that 23 does not meet the criteria for validity. When we scroll down to the histogram, however, for Region 5, we show that it is normally distributed. Now, let's go down. And as you know, we've already violated two of the three criteria. So I have gone ahead and conducted the Mann-Whitney test. But before that, let's scroll down to the test of normality. So when we scroll down to the test of normality, we look at the Shapiro-Wilk test. And so when we look at the Shapiro-Wilk test, when we look at enrollment in Region 1, we have a significance of less than 0.001. When we look at enrollment for Region 5, we have a significance of 0.088. We know that with 0.001, that is less than 0.05, so the normality is not met there. We also know that for 0.088, when we're looking, it is greater than 0.05, so normality is assumed here. We also know that we saw through the data that all three criteria were violated. So we now run the Mann-Whitney test, which is similar to the t-test. When we look at the Mann-Whitney test and we look at the significance, it is 0.229. So this number is greater than 0.05, which denotes that there is no statistically significant difference in enrollment between regions 1 and 5. So now to get to the data for my analysis, I performed an independent samples t-test. And let's not forget the test of homogeneity of variances based on the mean. That is 0.001. Again, that variance is not met. So when we look at the independent samples test, we look at all of the data. And again, when we look at enrollment for Region 1, the enrollment is 72. With a mean of 2,353.75, a standard deviation of 4,005.16. For Region 5, we have a number of 23 with a mean of 987.83, with a standard deviation of 490.22. When we come down and we look at the independent samples test, of course, I did this test based on the equal variances not being assumed. So with that in mind, my t-value will be 2.82 with the degrees of freedom at 77.26. As stated in our class on Thursday night, it's best to lean towards the two-sided p-value. And so that two-sided p-value is 0.006. And when we look at the homogeneity of variance test for those numbers with equal variances assumed, it will be 0.011. Now we've also done an effect size test. So when we look at Cohen D, the effect size focused on this point estimate is 0.38. Now I want to share with you my APA interpretation. So, an independent t-test was conducted to determine if there were differences in enrollment between two regions. An initial pre-test checklist was conducted to determine if any criteria violated the assumptions of normality in analysis. There were significant differences in district enrollment between Region 1 and Region 5. Region 1 had greater enrollment than Region 5. In APA style, in this report, Region 1, which had a means of 2,353.75 and a standard deviation of 4,005.16, and Region 5 with the mean of 987.83 and a standard deviation of 490.22, and also had a t-value of 2.82 with degrees of freedom at 77.26. Our p-value was 0.006 and our coincidence d was 0.39. Because our p-value was less than 0.05, we rejected the null hypothesis. The coincidence d of 0.39 indicates a small effect size. This concludes my analysis.